Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on adapting the fighting fantasy rules to a Twine game using the Sword and Planet subgenre of science fiction to inform the setting and plot. Yesterday, or last video, we looked at automatically testing our game. What I mean by automatically is instead of, or rather as well as, playing the game ourselves and making the choices and making sure that it all does what we thought it was doing and making sure that all the links go to the right places and that the plot is as we expected and that the writing makes sense and so on. We also want to have the computer simulate playing the game and give us results about things like how many characters lived and how many died. Does one character tend to do better than another? Which particular parts of the game are frequently visited and which ones are rarely visited? And of course, this information can help us with adjusting the balance of the game, making characters stronger or weaker if they're too strong, pegging them back a little bit, and so on. Because computers are much faster than humans in doing sort of these sort of operations, we can get results on several hundred simulated games in a few seconds. So we want to set up a system for automated testing, although that doesn't mean that we want to stop testing ourselves, because there's certain things that computers can't really give us useful feedback on, like whether the writing is clear, for example. It's very difficult to get a computer to give you, information about that sort of thing. But of course, if we want to send the computer through 400 simulated runs of the game, that's no use if the computer isn't playing the game properly, right? We want to make sure that the computer starts at the start and that when it makes a choice, it goes to one of the two choices, and that when the game's telling it that it should roll 2 dice and compare that to the character's skill, that's what it's doing. It's not ignoring that or always counting it as successful, or whatever other errors an algorithm might have. So before we do sort of multiple run-throughs of the game, we need to program a system which will do one run-through of the game and tell us what it's doing step by step, and then we can look at that and make sure, yes, it looks like yep, that choice is the one that should be there, and you've told us you've made this choice, and if you made that choice, you should go to that paragraph, and it looks like, yes, you do go to that paragraph, and so on. And I showed you most of a system to do that in the last video. The exception was combat, because combat is probably the most rules-intensive part of the fighting fantasy system, at least of its core rules. And so I thought it was worth giving that a separate video. So here we see an example of a run-through. It's told us that it's chosen character 2 out of 4. Every time it has a choice, it just chooses randomly. It's telling us the skill, stamina, and luck, so the attributes of the character that it's using. Then it gives us the text for the first few paragraphs, and eventually we get to this combat against this pit creature, and it's giving us the details of that. It says the player rolls 6 for an attack strength of 14. Well, the way that combat should work is that it should roll 2 6-sided dice, or simulate doing so. Well, 6 is a result you can get by doing that. And then you add the player's skill, which in this case is 8, to get your attack strength. And yes, we see that we rolled 6, and when we add 8, that does make 14. Then we have the pit creature's attributes, and they are what they should be in the game. And we see that it rolls 7 for an attack strength of 17, which again makes sense because the creature's skill is 10. And because the creature's attack strength is higher, it got 17 and we got 14, or the player got 14. The player should be wounded, and indeed the player is wounded. And then we see another combat round. In this case, the player is again wounded with a 21 attack strength versus 13. Because the pit creature has a skill of 10 and our character has a skill of 8, we would expect that the pit creature would be wounding more than it is wounded. And then finally we see that the player escapes. Some fighting fantasy battles you have the option of escaping, and this is one of them. So that seems to make sense. And then the story goes on until eventually we get to a section that isn't yet written. So we can see through by looking at this that it all seems to be operating. It all seems to be doing what it should be doing. So let's spend the rest of the video looking at the code that allows that to happen. So here we are in the game, and the thing that we're going to look at mostly is these 3 pages here. It starts with this one, goes briefly to this one, then to that one, and then if there's another round of combat, it loops around. So just to refresh your memory on how the which part of the program is where, we start at the initialize screen. This sets up all the variables. It also gives the user the choice of whether they want to play the game or test the game. And at the moment, we're only doing the sort of testing where we run through the game once. We haven't yet done the programming for multiple runs of the game. So of course there'll be 3 choices when we do that, and then presumably if the game is finished and sent out for people to download and play, well, there'll probably only be one choice, so it won't be a choice, because this testing stuff is not for users of the game, it's for the programmer of the game. It's something that we want to look at so we can make sure that the game is doing what we thought it was doing, what we wanted it to do. And then when we've finished with that and we're happy with the game, we would presumably delete the pages relating to testing, or at least we would delete them in the version that we sent out. We might keep a version that for ourselves or for people that are interested in programming to look at, partly because we might want to use a similar system in our next game. And so having the code already there will sort of help us set it up next time rather than having to do it from scratch. But anyway, if you choose to test, you go to this page called one-off. Most of the testing takes place on this page called run through, but if combat ensues, then we go to these 3 pages. This is a little these 3 pages handle the combat, and then when that's finished, if the player's still alive, we go back to run through and continue. So it's entirely separate to the system for handling combat when playing the game, which is all of these pages. Basically, all of these pages down here. So as you can see, it's much more spaced out, having all those many pages rather than the 3. The version where we're testing is a little bit more compact, but fundamentally it does the same thing, with the exception that when you're playing the game, the player has various choices that they have to make sometimes, usually just whether to escape or not, whether to use luck or not, whereas when we're doing a simulated run-through of the game, well, the player doesn't make choices, the computer makes those choices, and it does that, of course, by generating random numbers. So let's have a look at the way that these 3 work. So I'll just zoom in a little bit. So the first thing we do is we add 1 to the value of $RO. $RO is the round. So as in round 1, round 2, round 3. Fighting Fantasy, like a lot of role-playing games, probably every role-playing game I've seen actually, divides combat into a series of rounds. The reason we need to keep track of the round number is that sometimes the player has the option to escape from combat, which means that they get out of a combat that presumably one that they're going to lose. They take a wound as they leave, or 1 wound for every opponent left alive, but they don't have to stay there and fight to the death. But sometimes that escape is only allowed on a certain round. So it says after the 3rd round you can escape, or whatever. At other times it'll say you can escape from the 1st round. At other times it will say that you can't escape at all. But in case it's the one where you can escape on a certain round, we need to keep track of what round it actually is. And then it says if random bracket 0, 1 is equal to 1, in other words, that is a straight 50% chance it will choose either 0 or 1. And if it has chosen 1, and these other things are true, $RO is greater than or equal to $ES, and $ES is greater than 0. So what does that mean? Well, $ES is where we store the round on which escape is possible. So if $ES is 4, that means the player can escape on round 4. If it's 1, it means they can escape straight away. But if it's 0, that means no escape is possible. So ES has to be greater than 0. In other words, it has to be a combat where escape is possible. $RO has to be greater than or equal to $ES. In other words, we have to have reached a round where escape is possible, and we have a 50% chance. So that 50% chance just represents player choice. The player has the choice to escape or not escape, and I've assigned a 50% chance to that. Now, that's not a very sophisticated algorithm. Probably a real player would escape if their stamina was low, would escape if their opponent's skill was higher than theirs, or perhaps if it was equal to theirs and they had multiple opponents. And we could have a more realistic kind of decision making about whether to escape, and that would give us better results, more realistic results that are more like what is likely to happen when other people play our game. But for now, I'm just using a very, very crude simulation of player choice, which is just you choose to escape or not escape. We'll probably, we may change that later to make it more sophisticated. But in any case, if all these things are true, the player chooses to escape. So we give that message so that we who are following along with the test can see what's happening. When you escape, you get a wound for every opponent left alive. So we have a for loop that goes from 1 to $OP, which is the number of opponents. Or it's the number of opponents that we had at the start of the combat. We might have fewer than that now. But let's say if we start fighting 6 goblins or something, then $OP will be 6, and it will stay at 6 even though we might only have 2 of them left alive, say. And then we look at $ST, square bracket $Z, end square bracket, and if that is greater than 0, then we reduce this, which is the attribute array, and that one is the current stamina. So the first number tells us whether it's skill, stamina, or luck. 1 is skill, 2 is stamina, 3 is luck. And the second number is 0 if we're talking about the initial value, the starting value, and usually that's the maximum value. or 1 if we're talking about the current value. So $AT21 is the current stamina, and we reduce that by 2. Minus equals 2 just means its new value is equal to its old value minus 2. So in other words, for every living opponent, you get minus 2 stamina. And then if your current stamina is greater than 0, in other words, if the player is still alive, then we set $TZ, which is the variable that's keeping track of which section the computer player is at. We set it equal to $S, $TZ 4. Why 4? Well, because that's just the slot where when we have a combat paragraph, we have a destination paragraph if the player escapes, if there is, or we just have NA if no escape is possible. And we have another slot where the destination paragraph or section if the player wins. They can be the same, but they might be different. And we happen to put the escape destination in slot 4. So we set the TZ variable to its new value, and then we go back to run through, which is the main bit where we're running the test. So if stamina is greater than 0, then go to the escape paragraph, the escape destination, and keep testing the game. Otherwise, we just give the message the player is dead. So that's if the player chooses to escape. We have that if, all that code is in there, and then if that's not the case, if the player has either chosen not to escape, so that random number didn't come up as 1, it came up as 0, or no escape is possible, either the round hasn't reached that point yet, or there is no escape, then we go to test combat, which is up here. This is a very quick one, and as the comment says, it says randomly select an opponent from all opponents whose stamina is greater than 0. Again, we could do probably better than randomly selecting. We might select the opponent with the lowest stamina. We might select the opponent with the lowest skill, because you're more likely to win against them. But again, I've done the simplest thing. But of course, because it's the simplest thing, and because it doesn't really resemble what real players would do, it doesn't give us the best possible results. But it's a start. I generally try to go, let's just do the simplest version of this, and then we can think about making a better version later. So how do we randomly select an opponent? Well, we set $Z equal to a random number from 1 to $OP, so to the number of opponents. Now, if we only have one opponent, well, obviously it's always going to be 1. But this is relevant when you have multiple opponents, because when you have multiple opponents, you still have to fight against all of them, but there's only one that you can wound. If you fight 6 goblins and you beat all 6 of them, you don't wound all 6 of them. You only wound the one that you chose to sort of focus on in that round, but they can all wound you. So we randomly choose an opponent, and if $ST, which is the array where we keep the enemy's stamina, if $ST square bracket $Z end square bracket is greater than 0, in other words, we've chosen an opponent that's still alive, then that's great. We go to test combat 2. And if that's not the case, we've chosen an opponent that we've killed, well, that's no good. So we want to go to or include test combat. In other words, try again. Choose an opponent. No, not that one. That one's dead. So once we've chosen an opponent that is still alive, and there will be an opponent still alive, because at the end of the round, we're going to check, and if they're all dead, then the player has won. So if we're here, we know that there'll be at least one that is still alive, and so we won't be in an infinite loop. Provided that we've set up the numbers properly in initialize, because I suppose we could have an opponent with a stamina of 0, and then that would cause it to cycle in this page endlessly until it crashed. But assuming we haven't made that mistake, assuming we, the programmer, haven't made that mistake, then there'll always be an opponent that's alive. and we'll always end up eventually going to Test Combat 2. In Test Combat 2, if $OP is greater than 1, then give that message. In other words, if we're fighting more than one opponent, then give the message player targets opponent 2 or 3 or whatever it might be. If the player only is fighting one opponent, well, there's no point going it targets opponent 1, because we know that we, the person watching the test, will know that that's the one that's targeting, because it's the only one that can be targeted. So we roll the player's attack strength. So we set Y equal to a random number from 1 to 6 inclusive, plus another random number from 1 to 6 inclusive. And then we set X, the attack strength, equal to the player's current skill plus that roll. And then we just tell the viewer that that's what's happened. Then we have a for loop, and you'll notice that in the for loop we're using Y because we need to keep X because that's the attack strength, but we don't need to keep Y, which is the roll. We only once we've said either they rolled 7 or they rolled 5 or whatever, we don't need to remember that number anymore. So we can use the variable Y in our for loop. So the for loop goes from 1 to $OP, and if it goes down to here, and all of it is within a single if, which is if $ST square bracket $Y end square bracket is greater than 0. And the reason it's all within that is because that's the stamina array. Well, if $ST $Y is not greater than 0, then that means the opponent is dead. And if the opponent's dead, we have no further interaction with them, right? They're out of the combat. So if they're alive, then we print $ED square bracket $Y end square bracket, which is the name of the enemy, and then we print their skill, and then we print their stamina. You notice that for opponents, we don't have that distinction between initial skill and current skill, or initial stamina and current stamina. We need to have that distinction when it comes to players, because sometimes the player might, for example, regain a certain amount of stamina, but the maximum would be a limit. Usually the maximum that you can get up to is your starting value. So in other words, if you read the original game books, it will often say gain 4 stamina, but your stamina may not go over its initial value. So if you had a starting stamina of say 13, actually I don't think that's possible. Let's say you had a starting stamina of 20 and your stamina was 18, and it said gain 4 stamina, but don't go over the maximum, don't go over your initial value. Well, you'd only gain 2. You'd go from 18 to 20, not from 18 to 22. That's why we keep track of that initial value. But so it's not necessary for monsters or opponents who we're only going to see for a single combat. So we have just a single array for skill and a single array for stamina. Then we roll 2 dice. We create an attack strength, which is their skill plus their roll. We tell the viewer, the user, that that's what's happened. If Y2, the attack strength, is greater than X, the human's attack strength, well, that means that the player is wounded, and therefore we give that message. We give the message that the player is wounded, and we reduce their current stamina by 2. Else if $X is greater than Y2 and $Z is equal to $Y. So there's an extra requirement here which isn't true for the opponents. The opponents will wound you if their attack strength is higher. You will wound a given opponent if your attack strength is higher, and if they are the opponent that you are targeting. So up here when it says player targets opponent 3, that means opponent 3 could potentially be wounded if Z was equal to 3. And if that's the case, then we say $ED square bracket $Y in square bracket is wounded, $EDY being the name of this particular opponent is wounded, and its stamina goes down by 2. And we do that for every opponent. Then, if at the end of that, the player's stamina is less than 1, they're dead. So obviously nothing more is going to happen. We just need to tell the user that. Otherwise, now we need to check whether any opponents are left alive. And we're going to do that with the $Z array, because the $Z variable, even though we use $Z for which opponent the player is targeting, well, that's okay. We don't need to know that now because the round's over. We don't need to remember that they targeted opponent 3 or whatever. We can reuse that variable. So we set Z equal to 0, and there's a note that says it's going to be set to 1 if any opponents are left alive. And indeed, we have a for loop that goes from 1 to $OP. If the particular slot of the $ST array is greater than 0, then Z is set to 1. In other words, look at every opponent's stamina. Are any of them above 0? And if so, set Z to 1. And if that doesn't happen and Z is still 0, well, we know that the player has conquered. They've killed all of their opponents. So if Z is equal to 0, and the player is still alive, because remember, this is all this code is within this else. We have this if the player stamina is less than 1, then we say the player is dead. We don't need to look at the opponents. It's possible. Sorry, it isn't. I was going to say it's possible for the player to die and all the monsters to die, but that's not actually true. So if Z is equal to 0, meaning that the player has killed all their enemies, then we set TZ equal to $S, $TZ3. That happens to be the slot where we keep the victory destination, whereas when we escaped on this page, we have very similar code, except that the number is 4. And that's just because we are keeping the victory destination in slot 3 and the escape destination in slot 4. That's just an arbitrary decision we've made. And we go to run through. In other words, right, the combat's finished. We don't need to be in these 3 pages anymore. Go back to run through and keep simulating the play of the game. And if that's not true, well, that means there's at least one opponent left alive. So we need to go to test escape. So back where we started, we increment $RO, and then we check for escape, and so on. And that is how that works. We can simulate a combat. The player doesn't make particularly good decisions. If you know Fighting Fantasy, or if you've seen videos in this series, you'll know that the player has the ability to choose to test their luck. In other words, roll dice and compare to their luck score to help either make a wound greater that they've inflicted or reduce a wound that they've suffered. And I haven't simulated that. Again, I'm just doing the simplest possible simulation. We'll just assume the player never chooses to use that option. And again, that's not quite what would happen in real life, probably, although it's closer to it. Actually, testing your luck to aid in combat is usually not a very good option. But yes, there are some circumstances where you would do it, and a more realistic algorithm would take that into account. But again, that's something we can perhaps add later, and that might give us more realistic results and therefore more useful results. But that's what we've done for now. So having set up a test, a sort of one-off test of the game that tells us everything that's happening at every stage, I've looked at those both in these videos and I've looked at them several times out of the videos, and they do seem to be working. So I think we're ready to move on to the next thing, which is that we're going to do more than one run through, and it won't tell us every paragraph that it's on and what's happening. It'll just go, right, I've done 10 runs through, and these, here are the results. And so that's what we'll be doing in future videos. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.